Hi, this is Carol Hobbs again, and I'm not doing Common Core for the parents. I have a special request from a couple of a former student of mine. This person is now in trigonometry, and so they asked me if I could do some videos with trigonometry. So we're going to start off with the secant of 19 pi over 4. Recognize that the secant is actually 1 over cosine. So there is a relationship between secant and cosine. See, the secant of theta equals 1 over the cosine of theta. So that's what we're going to use. Now in this case, if you notice, the numerator, ignoring the pi symbol, but the numerator is much larger than the denominator. So that says that this transaction has gone around a revolution at least 4 times, because 4 times 4 is 16, which is still smaller than 19. So we're looking for the reference angle, and once we subtract the 16 pi over 4 from 19 pi over 4, we will get the secant of 3 pi over 4. And I'm going to stop using red. I just thought about it. Some people have difficulty seeing red. Okay, so what is the secant of 3 pi over 4? That communicates a few things to me. First of all, it tells me that it's not in the first quadrant, because the first quadrant would be without the 3. It would just simply be secant of pi over 4. It is in the second quadrant, and in that case, secant as well as cosine represents your x values, and it's negative in the second quadrant. So we have 1 over the cosine of 3 pi over 4, which is actually a 135-degree angle, which is in the second quadrant. My top is still 1, but cosine of 3 pi over 4 is negative 1 over the square root of 2. If you look at the angle, this is 1, this is 1. So your x value, your cosine is 1, your y value, your sine is 1, your diagonal or your hypotenuse of this right triangle is square root of 2. So the relationship between cosine equals x over r. Okay? That diagonal is your tangent. So we have to do something else here. To help this process, we mathematicians do not, first of all, we have a complex fraction. So we need to eliminate or simplify the complex fraction. So we'll do that by multiplying the top and the bottom, the numerator, top, denominator, bottom, by the square root of 2. The effect is that the square root of 2 in the fraction, in the denominator, is canceled. So we have square root of 2 over 1, and because it's in the second quadrant, it is a negative square root of 2. Therefore, secant of 19 pi over 4, whose reference angle is the secant of 3 pi over 4, is simply the negative square root of 2. So let's look at another problem. Now in this problem, we're looking at the sine of 765 degrees. Again, we're looking for a reference angle that is between 0 and 360. This is more than 2 times 360. So if we subtract 2 times 360, which is 2 times 360 times 2 is 720 from 765, that gives us the sine of 45 degrees, which is my reference angle. Now the sine represents the y values of the point at 45 degrees. So therefore, that is and recall that the sine is actually y, the height over the diagonal. So that is 1 over the square root of 2. And to rationalize that, because we have this denominator, our denominator has a radical, and we mathematicians are a little quirky about having a radical in the denominator, we will multiply the top and bottom by the square root of 2. So 1 times the square root of 2 in the numerator is just the square root of 2. Square root of 2 times the square root of 2 in the denominator is the square root of 4, and the square root of 4 is 2. So that says my sine of 765 degrees exact value is the square root of 2 over 2. So now let's look at a third problem. Here we have the secant of pi over 6. If you will recall, the secant equals 1 over cosine. So that would be the cosine of pi over 6. That is a 30-degree angle off the positive x-axis. So that is actually the square root of 3 over 2. We have a complex fraction again, so to simplify this, I'm going to multiply the numerator top and the denominator bottom by 2. The effect of doing that is to cancel the denominator in the denominator. Now we have 2 over the square root of 3, and we do not like to have the radical in the denominator, so we're going to multiply the top and bottom by that denominator. So 2 times the square root of 3 is just 2 square root of 3, and 2 is the coefficient of this radical. Coefficient is the number generally to the left of your variable, and that's the number you use to add, subtract, multiply, and divide. But especially in this case, you use the 2 and the square root of 3 if you're multiplying and dividing. But if you're adding or subtracting radicals, what's under the radical symbol must be exactly the same. So back to this problem. Square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. So the secant of pi over 6 is 2 square root of 3 over 3. Now for the last problem we're going to look at today, will be the cotangent of pi over 3. These are all radians, pi over 3. Now, cotangent of an angle, I'm using theta, is actually the cosine of theta over the sine of theta. The cosine of theta, pi over 3, theta is pi over 3 in radians. So, cosine of pi over 3 is 1/2. The sine of pi over 3 is the square root of 3 over 2. As you see, I have definitely a complex fraction, a fraction over another fraction. So with multiplication, with division, because that's what we're doing with this particular problem, we're dividing the 1/2 on top by the square root of 3 over 2 on the bottom. So we will keep the 1 over 1/2. We change division to multiplication, and we flip, or we take the reciprocal of square root of 3 over 2. Notice that I'm in a position where the 2's cancel, or simply we divide both by 2, and that gives us 1 for both of those. So 1 times 1 is 1. 1 times the square root of 3 is the square root of 3. And you know I'm quirky, so I want to rationalize the denominator by multiplying the numerator and the denominator by the square root of 3. So 1 times the square root of 3 up top is just the square root of 3. Square root of 3 times square root of 3 in the denominator is actually the square root of 9, and the square root of 9 is 3. So the cotangent of pi over 3 is the square root of 3 over 3. Thank you. Have a good night.